Let's take what we've learned in the previous presentation and attempt to determine where the white lines in this image are. This is data from the RoboJackets team on their competition for the Intelligent Ground Vehicle competition in 2019. So here what we're going to do is we're just going to play through the video of what the robot is actually seeing. So this is from their actual competition run, and we're trying to detect the white lines that you can see in the image. So a common issue that we had when I was on this team was that if we ever tried to do any color filtering, one, it was very noisy, and two, we'd always pick up those barrels that you can see in the background. Their white edges often show up in color detection because when you're looking for white, you get everything that's white, not just the white things that you care about. So here are some representative images from the thing that we're going to be looking at for each different way of doing color filtering. So remember we have RGB, so let's try using RGB. It's a really simple color system. Let's do some detections based off of it. So this is the output of a detector, and what you can see here is anytime a pixel is black, that means that we've detected it and we think this is a white line. So what we can see here is we actually do pretty well overall. There's definitely some noise here in the center of the image. But as the robot drives, and you can see the brightness level change, that's when you get this flicker of the black. But you can see in the background, we're completely detecting those white lines on those orange barrels. So here again are some representative images from those. As you can see, we're detecting the white on the barrels, but we're doing a pretty good job overall. There is some noise in the image though. So let's try looking at a different color space to see if we can do better than this detector using some other color space. So we're going to be looking at HSV, as we talked about earlier. So this is what it looks like if we run the HSV detector. What you can see is, unlike the RGB, we get a much less noise in the center of the image, and the lines seem to be a little bit thicker. So it's a little bit easier to detect the pixels that are around the lines than it is with the RGB. And the other thing that's very important is, as you can see in the background, we're actually not detecting the white on the barrels. So you don't have to worry about that as much with this color space as we did with the RGB color space. And this is due to the fact that the different color spaces allow us to threshold by different values. So here are some representative values, and we're comparing RGB to HSV. So as you can see here, we get thicker lines, and also we are not detecting the whites in the barrels. So next we're going to talk about some really cool tricks to get better values out of a color detector. So these things are called morphological operators. And these are essentially a set of operations to an image that relate to shape or features. And essentially we're focusing on the relative ordering of pixels. So all we're going to be using is that detection mask that we did earlier, which represents white line versus not white line. And what we're going to use is some morphological operators to refine these shapes. So the first thing we have is an erosion. And what the erosion does is it takes a kernel and moves it across the image. And the value at a specific pixel is the minimum of all of its neighbors. So what you'll see here is if we take this 7, and we apply an erosion to it, what you actually get out is this thinned out 7. Erosions are really helpful for removing noise. Often what we see in those images, when you see all those flickering pixels in the center, those are called salt and pepper noise. And as you can see here, this small t gets immediately erased by the erosion. Here's what that looks like if we apply it to our video again. So what we can see is we've applied the erosion, so we have essentially no noise in the center of the image like we had before, but the problem that we have is our lines are very thin. But as you can see, even the cursory detections that we have around the barrels are gone now. So before we used to get a little bit of an outline from the barrels, but now we don't, because we've applied an erosion and it has removed those. What you see here on the far right is a really great example of the problem with erosion, because what it's done is essentially removed most of the center of our line. So the next thing we have is a dilation. A dilation sets the value at a pixel to the maximum of its neighbors. So if we have the exact same images we had before, they essentially increase in thickness. If we apply that to our video, what we can see is we've taken the lines that we had before, which seemed a little thin, and we've thickened them. So now our robot probably has a better determination of where the actual lines are, and as you can see, there's a couple places where we're able to fill in the values, but whenever there's noise, it completely takes over the entire image. So here are some representative samples from that. So as we can see here, we have these really thin, scraggly lines here from the actual HSV detection, but after we've applied a dilation, we get a really thick, nice line that we can use for detection. But at the same time, the noise, which shows up a little bit here, will show up greatly here. So now we've kind of run into an unfortunate trade-off. With an erosion, we've removed the noise, but our lines are very thin. And with a dilation, our lines are very thick, but the noise has been blown up. What happens if we apply these two operators in series? So that is called an opening. What you're going to do is apply an erosion and then a dilation. And what this is really good is for removing noise, but at the same time, you get out essentially the same size detection that you had originally. So we apply that to our image. What we're going to see here is this. Now we have none of the noise in the center, and at the same time our lines are not super thin. So there is some noise that still comes through, but it's a lot better than what we had on the original detection. But as we can see here, there's a couple issues where we have lines that are not fully filled in. It would be really nice if we could do something that would fill those lines in. So here are some representative samples, and what we can see here is, wow, we're really great at removing noise. As we can see, this whole patch of noise is mostly removed. A couple of the salt and peppers are removed, but what you have is this line is not filled in. If we apply the morphological operators in the opposite direction, we have this thing called closing. And what closing is really good for is filling in gaps. So if we apply a closing to our video, what we can see here. So now what we have is, see how those lines are fully filled in most of the time? This is because we've applied closing. But as you can see, we have lots of noise that still shows up, because closing is not good for removing noise, it's just good for filling in gaps. So as you can see your representative samples, we're doing much better about filling in our line here at the far right, but we still have a lot of noise. So you can apply these operators in any sequence that you would like. So what I'm going to show you here is I'm going to do an opening, and what that's going to do is remove noise, and then I'm going to apply closing, which is then going to hopefully fill in some gaps. This is the final detector I was able to output for this bag file with a couple hours of tuning. What you can see here is we have pretty decent lines, but also most of the noise is gone. So you can see some repetitive samples here of our closing and then opening operation. So this was an example of how we use detections, and one of the key things here is that I was using my domain knowledge, that lines are typically filled in. So if I have some detections on the outer edges, I should also have detections on the inner edge, and that is why I was able to apply something like closing. And then also that I shouldn't have small detections of lines in the center, and that's why I was able to apply something like opening. So as you can see here, one of the most important things when you're debugging stuff like computer vision is getting nice visualizations so you can see what you're detecting compared to what you're not detecting. Remember how I talked about how tuning is hard? Well, here's what I did. Here's an image. Here's a video from 2017 when I first started doing IGBC. And what you can see here is this looks very similar to what we had before. So you're like, oh, the detector will probably work really well. Well, it turns out, so this is our RGB detector, and as you can see, there's significantly more noise in the image because the brightness on this day is just different. Therefore, tuning the detector becomes a lot harder to handle those changes in brightness. And now you're like, oh, HSV was the way to go. Here's what happens if I use the same values for HSV that I had previously. And what you can see here is this is completely garbage detection. So the important thing to remember is that how you tune things will matter day to day.